In this video we will see mechanic refrigeration and air conditioning semester 2 and the various component of refrigerator like compressor, motor, condenser, expansion valve, tires, evaporators, refrigerants, retrofitting, thermal insulation, window air conditioning, split air conditioning, car air conditioning, and then at last we will see the different types of questions. So we will discuss one by one everything, and I will try to cover most important parts of this all parts of refrigerator, and I will complete everything in as fast as possible, and in there these will be in short. So let's begin. The compressor. Okay, this is a compressor. You can see this portion is called crankcase. This is crank, and the entire case is called the crankcase. This is connecting rod. This is piston. This is inlet port. This is outlet port. And when okay, let's see its operation. This top portion of the piston is called TDC, that is top dead center, and when the piston travels downward direction, then the extreme position where it comes is called the bottom dead center. This is a top dead center, TDC, and this is called the bottom dead center. Extreme below condition is bottom dead center. Okay, so when piston comes downward direction, its inlet valve open and the refrigerant flows inside the cylinder, and when the piston moves upward, this inlet valve closes, and after reaching the top dead center, the exhaust valve opens and refrigerant passes through here. Okay, this is a process, second process of compression process. This is a suction process basically, where piston is coming downward and sucking refrigerant vapor, and this is a compression process where the pressure has raised by the pistons, and it has come from here, exhaust port. This is exhaust port. So this is a basic operation. Okay, so let's discuss different phenomena, different terms. So we know that compression stroke. This is the compression ratio. Compression ratio, it is the ratio of total volume to compression to clearance volume. Total volume means clearance volume plus stroke volume, and you know that stroke is the movement of piston from top dead center to bottom dead center, or bottom to top dead center. So that is stroke, and the compression ratio is ratio of total volume upon clearance volume. And weight compression takes place when small particles of unvaporized liquid from evaporator are compressed by the compressor. Okay, unvaporized liquid from the evaporator are compressed by the compressor. When the vapor contains some amount of water droplets, liquid droplets, so that is getting compressed by the compressor, so that is called weight compressor. So this advantage of the weight compressor is that it keeps the compressor cool, since the condition of refrigerant is still in liquid condition. Droplet is there, so that works as a coolant for the compressor, so it keeps cool the compressor. But the disadvantage of weight compression is that the compressor compresses the liquid instead of vapor, which applies extra load on the electric motor. Okay, this is the advantage of weight compression, that it keeps the compressor cool, and disadvantage is that weight compression is that the compressor compresses the liquid instead of vapor, which applies extra load on the electric motor. Okay, it requires additional load on electric motor. We have seen the clearance volume and the clearance pocket. Okay, let's see the clearance pocket. What is the clearance pocket? Okay, this is suppose this is inlet valve. Okay, and this is our piston. So the clearance gap, there is a gap between this valve and the piston top dead center, top surface of the piston. This gap, when it comes to the top dead center, this gap between this valve and piston is called the clearance pocket. So if the clearance pocket is increased, so the volumetric efficiency of the compressor is decreased. Okay, the volumetric capacity efficiency is the breathing capacity of the compressor. How much volume of the fluid it is taking. So that is called the volumetric efficiency. Compressor speed, the compressor speed is measured by you know that the device tachometer, and it is measured in revolution per minute. It is measured in revolution per minute, and there are different parts which belong to the low side of the compressor or low pressure side of compressor are suction service valve. Okay, this part has a low pressure crankcase. Crankcase 2 have low pressure soft seal, cylinder on suction stroke of the piston, suction valve, half portion of the piston, and the parts of compressor which belong to high side means in these parts the pressure will be high. So cylinder discharge valve, obviously discharge valve will be the of high pressure, cylinder on compression stroke of the piston, cylinder part when there is a compression stroke, so that part will be also high pressure region, half portion of the head plate. Okay, material of compressor components, these are the piston rings. See here, the compressor pistons are made of cast iron or aluminium. Okay, compressor pistons are made of cast iron or aluminium. Piston rings are made of cast iron. Okay, piston rings are, remember that the piston rings are made of cast iron, and the pistons are made of cast iron or aluminium. Also remember that the crankcase is made of either forged alloy steel of considerable strength of spheroidite gray cast iron in casting. Okay, this is a crankshaft. Crankshaft is made of forged alloy steel. Remember this. This is made of forged alloy steel. Lubrication of compressor. There are two types of lubrication system: splash lubrication system, force feed lubrication system. When there is low speed of compressor, then the slow speed for slow speed splash lubrication system is used, where there are lubricants on crankcase which this see here, the splashers are fitted with the crank or eccentric shaft. These splashers pick up the oil from the bottom and throw it on all parts of the compressor. Okay, in crankcase portion the lubricants are present, and some bucket kind of things are there which are called splasher, that pick up the oil from the bottom and throw it in all parts of the compressor. Okay, in that way it keeps lubricant. And the second is forced feed lubrication. This is used for high speed purpose, high speed compressor. So it is just a oil pump fitted on end of the compressor shaft. Okay, and that oil pump pumps the or injects the lubricant on the parts of compressor. So in that way it lubricates. So now let's see the classification of reciprocating compressor depending on working. First is depending on working. These are single acting and double acting. Depending on construction, vertical, horizontal. Depending upon the coupling of motor, open type, semi hermetically sealed, hermetically sealed. Okay, now let's see the first is depending on working principle. So the two types, single acting and double acting. So let's see, the main difference is that in case of single acting compressors, the compression of the vapor takes place only in one side of the piston, which is once during each revolution of the crankshaft, whereas in case of double acting compressor the vapor compression occurs twice during each revolution of the crankshaft. Okay, single acting means there is a single action of for compression action to the refrigerant, and double acting means either side of the piston there will be refrigerant which will compress so in both sides. So in double acting there will be it will require more maintenance and more lubrication, and temperature pressure will be definitely higher in double acting, so it will require more maintenance. The second was horizontal and vertical. So that was just the position of the cylinder. And now let's see the open unit. In open type unit, in which the prime mover drives the compressor by means of belt. Okay, in there is a belt arrangement. In such a unit, prime mover and compressor are separately serviceable. Okay, so that was open unit and hermetically sealed unit. This is important. In domestic refrigerator we use hermetically sealed unit. Let's see what is this. So in ordinary compressor, the crankshaft extends through the compressor housing and is connected to the driving motor. Okay, a seal must be provided at the place where the shaft comes out through the compressor housing. This is necessary to prevent leakage of refrigerant outside a leakage of air. To avoid this problem, the compressor and motor are enclosed in one housing, which is known as hermetically sealed compressor. Okay, the compressor and motor. This is the motor and these are the pistons, compressor. So these are sealed by some kind of arrangement, and these are sealed in one single system. So this motor is not separated with this, so this is called hermetically sealed compressor. See here, this type of compressor are normally used for a small capacity refrigeration system as household refrigerator. In our household refrigerator, these type of system are used. The main parts are electric motor, compressor, muffler, dome. Okay, let's see the advantage of hermetically sealed compressor is that the leakage of refrigerant is completely avoided. Okay, since both are in one single unit, so there is no leakage. It is less noisy because compressor and motor both are inside the sealed unit, so it is less noisy. It requires less space. Okay, the motor and compressor assembly is mounted in the unit in such a way that usually the motor is fitted on the top and the compressor on the bottom. Okay, the motor is on the top position and compressors are in bottom condition. Motor cool it dipped into oil and the bottom of the compressor is fitted at the top. The oil is forced to the compressor through the shaft of the motor. Sometimes the motor and compressor assembly is hung on spring unit and sometimes it is a press fitted. There are two types of compressor which are used inside the sealed units: reciprocating compressor and rotary compressor. The electric motor used in sealed units are solid split phase induction motor, capacitor start induction motor, capacitor start capacitor run motor. Okay, so these are the type of motor which can be used inside the sealed unit. Now let's see the scroll compressor. Scroll compressor, also known as scroll pump and scroll vacuum pump. Okay, uses two interleaved spiral-like veins to pump or compress the fluids such as liquid and gases. Two interleaved spiral-like veins to pump or compress the fluid as liquid and gases. Okay, a scroll compressor has fewer moving parts than reciprocating compressor, so it operates more smoothly, quietly and reliably than conventional compressors. Okay, so it has low moving part, less moving part, so it can operate smoothly, quietly, reliable and then as compared to conventional motors. The compression process occurs approximately 2 to 2.5 rotation of the 2.5 rotation of the crankshaft. And there is another important part is that the scroll compression process is nearly 100% volumetric efficient in pumping the trapped fluid. See this is a scroll compressor where two interleaved parts are spiral-like veins are used to compress the fluid. Okay, let's see the rotary compressor. A rotary compressor is basically, it do not use piston cylinder arrangement, and rotary compressor is that compressor which compresses the gas by rotary motion of the roller in an enclosed cylinder. Okay, there is a roller inside the enclosed cylinder which compresses the gas by rotary motion. So there are two types: stationary blade type rotary compressor, rotary blade type rotary compressor. Okay, this is a stationary blade type rotary compressor where this is a roller and it is in eccentric direction in eccentric ways, and it is rotating like this. This roller is rotating like this, and the compressing this gases. In rotary blade type rotary compressor, this cylinder is in concentric manner, and this inside part of the compressing area is divided by 4 blades. This is 1 2 3 4, so this is the only difference, and everything is almost same. Now let's see some difference between the rotary and reciprocating compressor. In reciprocating compressor compresses the gas by reciprocating motion of the piston in enclosed cylinder, but in rotary compressor it compresses the gas by the rotary motion of the roller in an enclosed cylinder. And it can be single acting or multi-cylinder compressor, but it has only one cylinder. It can be used in domestic as well as commercial refrigerating machine. It is used only in domestic refrigerating machine. A suction valve is used to suck the gas. Check valve is used instead of suction valve. Crankcase and bottom of the compressor is in the low side, and main dome of the compressor is in the high side. So these are the difference. This is the advantage of rotary compressor over reciprocating compressor. Rotary compressor are more silent in operation and free from vibration. Okay, the compressor works satisfactorily with refrigerants having high specific volume at low suction pressure. It is preferred for low temperature application. But there are also limitation of rotary compressor, that is the suction and discharge port are fixed in relation to the rotary components of the compressor. It works for a specific set of suction and discharge condition. Okay. And rotary compressors are suitable for application where the operating conditions are relatively with a particular range, such as domestic refrigerator and home freezers, room air conditioners, etc. It cannot be used for industrial purpose or commercial purpose. It is suited for low pressure ratio application. These are the disadvantage of rotary compressor. Centrifugal compressor, we know that this is a widely used type of compressor, and it is used in for large application. This is a centrifugal compressor where you can see that this is inlet, this is the outlet of the compressor, these are the impeller, and this middle portion is called eye, and after compression this is going through this volute casing, which is rising its pressure. Centrifugal compressor are used for large air conditioning plants. And let's see the different types of merits of centrifugal compressor over reciprocating compressor. So let's see, a single centrifugal compressor can be used instead of many reciprocating units, thereby reducing the requirement of space. Okay, so the centrifugal compressor can reduce the space requirement, so it is better than reciprocating compressor because it reduces the space requirement. And the centrifugal compressor can be used for installation as big as 5,000 ton capacity and to get a wide range of temperature from 25 to -100 degrees centigrade. Okay, for this is the main reason that it is used for large air conditioning plants and for commercial purpose. And centrifugal compressor are more reliable. Centrifugal compressors are of compact construction. Centrifugal compressors operate noiselessly. Okay, there are very little vibration or no vibration due to absence of unbalanced masses. Since in reciprocating compressor there are piston cylinder arrangement, so there may be chances of unbalancing force or torque on the system. You have to use flywheel on that crankshaft, so that there is a chances of vibration in reciprocating compressor. But in the centrifugal compressor there is a low chance of vibration. Centrifugal compressor have low maintenance cost. Operation of centrifugal compressor is very easy. It has longer life. The demerits of centrifugal compressor over reciprocating compressor. Centrifugal compressors are not found suitable for smaller capacities. Okay, these are not suitable for smaller capacities. A phenomenon is called surging is experienced in centrifugal compressor when the system load falls down considerably. Okay, this is a unwanted phenomena, surging. Now let's see the screw compressor. So screw compressor multi-start helical groups rotors. It consists of two meshing multi-start helically grouped rotors which were very closely clearance within a housing. The rotor whose shaft is connected to the motor is called the mill rotor. Okay, just remember this diagram. This is a screw compressor. This you can see that these are in screw shape. So screw compressors are merits of screw compressor over reciprocating compressor are that these are more reliable, have high volumetric efficiency, low vibration, less wear and tear of the moving parts, so it requires less maintenance as compared to reciprocating compressor. Another type of compressor is thermocompressor. Just see the diagram and just remember this works on the principle of Bernoulli's theorem, where velocity head is converted into pressure head by increasing the area of flow. Okay, just it works on the principle of Bernoulli's theorem, where velocity head when becomes zero, then it becomes pressure head. So where pressure head increases when velocity head becomes negligible or it becomes zero. So that is the theory behind this thermocompressor. Just remember this. Let's see some question related to the compressor. A compressor coupled to a motor externally is called sealed compressor, semi-sealed compressor, open type compressor, none of the above. So this is a not sealed because the motor is using externally. Semi-sealed, this is not semi-sealed, so this is open type compressor where we use belt to drive the compressor through the motor. Okay, the main part of the rotary compressor are cylinder and rotor, blade and crankshaft, valve and crankshaft seal, all of the above. In rotary compressor, this crankshaft arrangement is absent, so this is cylinder and rotor only. So this is the right answer and this is the correct answer. Next is hermetic system is used in refrigerator, window type air conditioner, bottle cooler and water cooler, all of the above. This is a hermetic system or sealed unit which is used in all low capacity. So the home window air conditioner, refrigerator and water cooler, this all in this all system the hermetic system is used. So option D is correct. Okay, which one of the following components creates flow of refrigerant in the system? Compressor, evaporator, condenser, expansion valve. So the compressor A is the correct answer because it is the heart of the refrigerator which circulates the refrigerant throughout the whole system. So the compressor A is the correct answer. Next is the cause of burnt out compressor motor is OLP defective. This OLP is overload protector which protects the compressor from burning or heating. So this is the correct answer. These are the thermostat defective, liquid line blocked, shortage of refrigerant. These are not the correct answer. Only A is the right answer. So from here we have finished the compressor section. Next we will see